This is everything that OGC stands for. It is this foundation on open standards and the value of interoperability, and this is a community of passionate people collaborating to use the technology, the standards, the innovation to produce results that can be taken into operations.
Within the GEO framework, many partners from different areas and also many countries are coming together to collaborate and to test much needed tools that are necessary to first responders or to decision makers during a disaster event.
Often when people talk about disasters, they're thinking about emergency managers and first responders. And they're absolutely critical being able to have the information we call the situational awareness to know what to do, where to do it, when to do it. But what's novel here too is that there's a host of other people, planners, resilience officers, citizens. And so the users and stakeholders on this are quite broad, and I think as we move forward, we're going to be reaching these larger and larger communities.
So I think the most subtle benefit of the OGC pilot is demonstrating the possible globally.
Health-related insights at the point of care can now be leveraged, identified, and geocoded, providing critical data to support emergency responses before, during, and after a disaster. For example, in the aftermath of Hurricane Maria, the lack of medical information for first responders resulted in a number of fatalities. This SDI-based solution ensures that the medical and health needs of the impacted population are known in advance and can be addressed.
I think the real value of the Disasters Relief Pilot is that we are showing that there are ways that FEMA can continue to improve in its ability to respond to natural disasters.
That health scenario is applicable not just to, we need to manage the healthcare system and we need to get the healthcare system back up and running because we've had a disaster. That health scenario is addressing day-to-day health issues.
Sounds easy, but without open standards, it probably wouldn't happen.
During a flood disaster, firefighters and FEMA teams literally go door to door, rescuing survivors, sometimes for weeks. Using the example of Tropical Cyclone Harvey, flood maps can be generated by bringing all kinds of data together, from storm tracking and rainfall forecasts from NOAA to satellite and field observations. Then, large-scale river models can be generated, predicting the scope of the storm event. Disaster managers can then know precisely where the flood is occurring and generate maps that can be viewed on mobile devices to support first responders.
Getting all of the maps from all of the various agencies and groups that produce all of the flood inundation maps, it's a huge range of methods and deliverables. But this serves to kind of try to bring that together and be a focal point for ultimately the emergency manager at the end doesn't really care who makes each individual map. They just need the right map at the right time.
Remote sensing allows for rapid, objective, and cost-effective assessment of extreme weather events. Thanks to automated workflows and standardized platforms, different available algorithms, high-resolution satellite imagery, and geo-platform, data and methods can be communicated and used to generate meaningful information for resource planners at the right time.
Interoperability is critical to our ability to pull together different data streams, and that need is only becoming greater as new technology enables new ways of pulling in data, but to fuse that into something that is truly value-added.
You couldn't do a project like this if systems and data and programs were not interoperable, and if the collaborations between agencies and other stakeholders weren't present at the table.
Spatial data infrastructures, or SDIs, can support more than flood disaster relief. For example, during wildfires and hurricanes. When firefighting resources are limited during a Colombian wildfire, what is the best way to respond? A national SDI brings a number of data sources together into a collection of curated objects. semantic concepts match resources to needs and help emergency managers avoid major hazards. For example, exposed toxic coal ash ponds. The same SDI can support an evacuation strategy during a hurricane in Haiti or seasonal flooding in Ghana.
Disasters happen somewhere. We need to respond and act somewhere to address the concerns of those disasters.
There have been 476 major landslide events in Chinese Taipei alone since 2006, causing more than 20,000 fatalities. During Typhoon Morakot alone, 9,100 people were evacuated, 1,046 escaped from possible casualties, and 673 people died. An early response plan was devised, bringing together monitoring stations and a network of diverse sensors providing real-time data. Leveraging OGC's interoperability and international standards, including Web Mapping Service, Web Feature Service, and the Sensor Things API, this solution for collecting and integrating data resulted in an early warning system that will ensure greater safety during landslide events.
Sustainability, resilience, recovery, a very positive message is one that I hope to see that we also obtain from this effort.
One of the most subtle benefits of this pilot is the impact it has on people in other countries and other places, where they can envision, if this could happen in Taiwan or in the United States, we could do it in our community.